Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help you understand what a function's derivative and its second derivative tell you about a function. This is extraordinarily important for the understanding of calculus, much more important than, say, being able to actually calculate a derivative, but knowing what it means and what it's telling you about a function is crucial to understanding the mathematics. So what I've done is I've put this kind of quick function up here that I just kind of made up, and this function has a domain from -5 to 11, if I counted that right. 1, 2, 3, 4, 5, and then all the way here to 11. We're going to assume it stops there. Now, we're going to talk about some different points here that I've labeled with the red dots and number them in order. And the first thing we're going to do here is we're going to go through and just talk about function values. And we're just going to kind of guesstimate numbers here for the function values. And then we're going to calculate derivatives. And to tell you the truth, we're just going to put plus or minus signs on the rest of this, plus, minuses, and zeros. So let's go through and do the function values first. So 0.1, the function value is roughly 2, right? Here, meaning that f of 1, 2, 3, minus 4 is about 2. Let's see, at 0.2, the function value is 1, 2, 3, 4, a little less than 5. Let's say about 4.7 is good enough. 3, 1, 2, 3, is a little more than 3, maybe about 3.1-ish. 4 has a function value of 0. 5, a function value of -2. 6, -1, 2, a little less than -3. Let's call it -2.9, good enough. 7 is about here. Not quite -1, let's call it about -0.8. Okay? So hopefully anybody watching this video, you can go through and verify these. Hopefully I have them all right, but function values are literally like, this distance on the graph and this distance on the graph and so forth. All right, now we're going to talk about this, values for the function's derivative. And again, another way to write the derivative is dy dx. And again, remember, this is the ratio of two differentials. Small change in y, actually infinitely small change in y over infinitely small change in x. And the very crucial, important understanding here is this is slope. That's what this is telling us. So if we go to 0.1 here, the tangent line, let me do this in blue, looks about like this. So numerically, it looks like it has a slope of about, roughly about 1.5 or so. All I'm really interested right now for this is just pluses and minuses here. So at position 1, let's just say that the slope is positive. Now, positive slope means the function's increasing. Now, while we're at this, we're going to talk about the second derivative. Now, the first derivative tells you what this is doing. The second derivative tells you what this is doing. You'll notice if I go back and draw a tangent line just before and just after. See how the tangent lines are decreasing. So the second derivative at 0.1 is some negative number, indicating the slope is decreasing. So first derivative is positive, indicating the function value is increasing. Second derivative is negative, indicating the slope is decreasing. All right, let's talk about 0.2 here, this one. Now, if I were to draw a tangent line, it would look something like this. So now I did kind of sketch this. Is that slope exactly 0? I think I had intended that to be the 0 there. We're going to call that a 0 slope. Definitely close enough. Now, second derivative. Look at what's happening to the slope. Look at just before and just after. The slopes, as you go left to right, are decreasing. See how we go from some positive number to 0 to some negative number. Okay? So the value of the second derivative at this point is some negative number. Actual numerical value not important for the discussion. Okay, 0.3. The function is positive, as we've already noted. The tangent line has negative slope, so the first derivative is some negative number. Actual value not super important for this discussion. Notice that the tangent lines, if I draw one just before and just after, the tangent lines are still decreasing. So our second derivative there at this point is still negative. Now, it's not super pronounced, but if you look carefully and you pick this point, and maybe this point, and you compare the slopes here here, and here, you'll see it. They're at least slightly decreasing. So I'm going to call that a negative second derivative and move on. Okay, point 4, that's this one. Function value 0. If I draw a tangent line, again, it has negative slope. I'll go ahead and draw it and leave it in there. Oops, first one was better. Yeah, good enough. So this is negative, first derivative. However, if you look carefully and you look at a tangent line like here and another tangent line well, to tell you the truth, I was thinking that was a 0 second derivative, but I don't anymore. If you look here, here, and one here, it looks like those slopes are ever so slightly still decreasing. So I'm going to go ahead and assign a negative value to the second derivative at point 4, ever so slightly, okay? Point 5, okay. Tangent line still has a negative slope, so our first derivative is negative, but this one here is where we're going to see a difference now. If you kind of inspect the tangent line here and here, you will notice that, and let me use my straight edge. And I'm going to do this in a different color here. Let's do green. Just before. Just after. And what I want to point out is the slope went from decreasing along this part of the curve to increasing along this part of the curve. So the second derivative is negative everywhere in this region because the slope is decreasing the entire time. But if you look carefully from this point on to about here, the slopes are all increasing, indicating a positive second derivative. So the second derivative has went from negative to plus at roughly this point right there. So I'm going to go ahead and assign a value of 0 here. I'm going to put that in red at 0.5 for the second derivative. Now that's kind of a special point on a curve. It's called an inflection point. And if you look at the graph, there's a property called concavity. In this region here, the graph is called concave down, or can be described as concave down. In this region to about here, it's concave up, and then concave down again. So the second derivative tells you where the concavity changes. Actually, it looks like it changes, I think, at 0.7 is what I had intended. So the second derivative changes sign at these what are called inflection points here. So I think I already thought I wrote it already, but assigned a value of 0 for the second derivative at 0.5. Okay, 0.6. Now you notice the tangent line. I had intended this to be basically a 0 tangent line. One could argue by the way I sketched it that maybe it's a small positive value. Let's just go ahead and put SPV for small positive value. Approximately 0 is what I had intended for 0.6 here for slope. But again, you'll notice the tangent lines. Look at the tangent line here. Goes from a negative number to about 0 to a positive number. So our second derivative at that point is now positive. Point 7. Tangent line here. Oops, I've been doing those in blue. Why don't we stick to that? The slope of the tangent line is positive, so our first derivative is positive. And you'll notice, again, look at the tangent lines. See how we're going from increasing in slope, and then after this point, they are decreasing in slope. So that's another spot of inflection there, where the second derivative is 0. Okay, so the first derivative tells you about slopes, right? So slope is positive. So the first derivative is positive. The second derivative tells you about concavity. If we look at the same point right here, the slope is decreasing, resulting in a downward concavity. That's where the second derivative is negative. We look at a point like right here. The slope is negative, but it has downward concavity. So the first derivative is negative at this point, and the second derivative is negative at this point, and so forth. So again, this is meant to be a video to just help you conceptually understand how the derivative and the second derivative relate to these graphs. I think I'll just leave that right there. Call that good enough. Have a great day.